So here in this question, we have a rational function given by 2x squared plus 9x minus 5 divided by x plus 5. We have to find its limiting value when x approaches negative 5. So first we are going to do a direct substitution. So we're going to replace the value of x by negative 5. So we have 2 times negative 5 squared plus 9 times negative 5 minus 5 divided by negative 5 plus 5. So negative 5 squared is 25 and 25 times 2 is 50 minus 45 minus 5 divided by 0. So in the numerator we have 0 and in the denominator we also have 0. So this is a case of indeterminate form. So this particular rational function is giving us an indeterminate form when x approaches negative 5. So that means x plus 5 is the common factor in both the numerator and the denominator. So we have to get rid of the factor x plus 5. So let's factorize the numerator. So the factorization of the numerator, which is 2x squared plus 9x minus 5, will be equals to, so we have x plus 5 times 2x minus 1. Now we are going to replace the numerator by this factorized value. So we have limit x going to negative 5. So the numerator will be now x plus 5 divided times 2x minus 1 divided by x plus 5. So we see that the common factor x plus 5 is present in both the numerator and the denominator. So they will cancel out, leaving us with 2x minus 1 in the numerator. Now we substitute the value of x. So we have 2 times negative 5 minus 1, which gives us negative 10 minus 1, which is negative 11. So this is going to be the limiting value of the given function. So here we need to determine the limiting value of the given rational function when x approaches 3. So let us begin by first substituting the value of x. So that gives us 3 squared, which is 9, minus 4 times 3 is 12, plus 3 divided by 3 squared, which is 9, minus 3 times 2 is 6, minus 3. So that gives us 0 over 0. So this is again the indeterminate form. Now we have to factorize both the numerator and denominator and get rid of the common factor. So here x minus 3 is the common factor. So we begin by factorizing the numerator. So we have x squared minus 4x plus 3. So we're going to factorize it by splitting the middle term. So we get x minus 3 times x minus 1. Now we are going to factorize the denominator, x squared minus 2x minus 3, again by splitting the middle terms. So we have the factors of x squared minus 2x minus 3 are x minus 3 times x plus 1. Now we're going to substitute this value back into a rational function. So we have in the numerator x minus 3 times x minus 1 divided by x minus 3 times x plus 1. So x minus 3 is the common factor in both the numerator and the denominator. So that gets cancelled out, leaving us with x minus 1 in the numerator and x plus 1 in the denominator. So we substitute the value of x. So we have 3 minus 1 divided by 3 plus 1. So that gives us 2 over 4, which is equals to half. So this is going to be the limiting value. So here we have to determine the limiting value of the given rational function when x approaches 3. So let us do a direct substitution here. So we have 3 raised to the power of 4 minus 81 divided by 3 squared minus 9. So 3 raised to the power 4 is 81. So we have 81 minus 81 in the numerator. 3 squared is 9. That gives us 9 minus 9 in the denominator, leaving us with 0 over 0, which is the indeterminate form. Okay, so we begin by factorizing the numerator, which is x raised to the power of 4 minus 81. So that can be rewritten as x squared whole squared minus 9 squared. Now we are going to use the identity a squared minus b squared is equals to a squared plus b, a plus b times a, which is x squared, minus b, which is 9. Now we go back to our limit. So we have limit x going to 3. So instead of x raised to the power of 4 minus 81, we write in terms of its factors, we have x squared plus 9 times x squared minus 9 divided by x squared minus 9. So we see that x squared minus 9 is the common factor in both the numerator and the denominator. So they cancel out, and that leaves us with limit x going to 3, x squared plus 9. Now we substitute the value of x. So we have 3 squared plus 9. So this gives us 9 plus 9, which is equals to 18. So this is going to be the limiting value. So we need to find out the limiting value of the given rational function when x approaches 2. So the first step is always to do a direct substitution. So we have 2 cubed minus 8 divided by 2 squared minus 4. So 2 cubed is 8. So 8 minus 8 gives us 0. Similarly, 2 squared is 4. So 4 minus 4 gives us a 0 in the denominator. So this becomes the case of the indeterminate form. Meaning we have to factor out some terms from both the numerator and the denominator. So let us begin by first finding the factors of the numerator, which is x cubed minus 8. So this can be written as x cubed minus 2 cubed. So we are going to use the identity a cubed minus b cubed is equals to a minus b times a squared plus ab plus b squared. So that gives us x minus 2 divided by multiplied by x squared plus 2 times x plus 2 squared, which is 4. Then we factor out the denominator, which is x squared minus 4. This can be rewritten as x squared minus 2 squared, and we apply the formula x minus 2 times x plus 2. Also we see, according to our given limiting value of x, x minus 2 is the common factor. So we find that it is indeed the common factor in both the two polynomials. So let us rewrite the given limit. So we have x approaching 2. So x cubed minus can be rewritten as x minus 2 times x squared plus 2x plus 4 divided by x minus 2 times x plus 2. So we can cancel out x minus 2. So that leaves us with limit x approaching 2, x squared plus 2x plus 4 divided by x plus 2. And this leaves us with 2 squared plus 2 times 2, which is 4 plus 4 divided by 2 plus 2. So we have 4 plus 4 plus 4, which is 12 divided by 2 plus 2, which is 4. So the limiting value is equals to 3. So here we have a rational function given by 8x cubed plus 1 divided by 2x plus 1. So we have to find its limiting value when x goes to negative half. So let us begin by substituting the value of x, which is negative half, in place of x. So that will give us 8 times negative half cubed plus 1 divided by 2 times negative half plus 1. So we have 8 times, so negative half cubed will be 1 over 8 plus 1 divided by 2 times negative half is negative 1 plus 1. So we have 8 times negative 1 over 8, which is negative 1 plus 1 divided by 0. So we get the indeterminate form 0 by 0 or 0 over 0. So we say that x plus half is the common factor. So we can also rewrite it as twice x plus 1 divided by 2, which is equivalent to half times 2x plus 1. So we say that 2x plus 1 is the common factor in both the numerator and denominator. So now we begin with the numerator. So we have 8x cubed plus 1, which can be written as 2x whole cubed plus 1 cubed. Now here we are going to apply the identity that a cubed plus b cubed is equals to a plus b times a squared minus ab plus b squared. So let us apply it. So that gives us 2x plus 1 multiplied to 2x squared, which is 4x squared, minus 2x times 1 is simply 2x plus 1 squared, which is 1. Now we are going to rewrite our limit. So we have limit x approaching negative half. The numerator will now be replaced by 2x plus 1 times 4x squared minus 2x plus 1 divided by 2x plus 1. As we have already mentioned, that 2x plus 1 is the common factor in both the numerator and the denominator. So it's going to cancel out, and that leaves us with limit x going to negative half 4x squared minus 2x plus 1. Now we're going to substitute the value of x. So we have 4 times negative half squared minus 2 times negative half plus 1, which is equals to 4 times negative half squared will be positive 1/4. So negative 2 times negative half is going to be positive 1 plus 1. So we have 4 times 1/4, which is 1. So we finally have 1 plus 1 plus 1, which gives us a limiting value of 3.